Dear students, welcome to my class. So last few days onwards, I am explaining about JEE mains previous year problems. Hope that you are all preparing for your JEE mains examination. So particularly, I will explain the problems, mathematics from the chapters permutations and combinations. It's completed. Now I am explaining the probability. Okay now. So in the today's class, let us see few more problems from the chapter probability. So let us start our class. So dear students, welcome to first problem. The first problem is when a certain biased die, be careful, when a certain biased die is rolled, a particular phase occurs with the probability 1 upon 6 minus x and its opposite phase occurs with the probability 1 upon 6 plus x. All other phases occurs with the probability 1 upon 6. Okay, all 6 phases are there. In all 6 phases, one phase occurs with the probability of 1 upon 6 minus x and its opposite phase occurs with the probability of 1 upon 6 plus x. Remaining all 4 phases occurs with the probability of 1 upon 6. Note that the opposite phases is the sum of the opposite phases is 7 in any die. If 0 less than x less than 1 by 1 upon 6 and the probability of obtaining a total sum is equal to 7, when such a die is rolled twice is 13 by 16. So the die is rolled how many times? 2 times it is rolled. Then what will be the value of x is saying. So on the whole, there is an unbiased die. Unbiased die means what? So in the biased die means what? So in unbiased die, each phase will have a particular number 1, 2, 3, 4, 5, 6. In unbiased die, we don't know that what number it will be. The same number it will be there on the opposite phases and adjacent side phases. That is called biased die. Such type of biased die is there. So what is the probability of obtaining one phase is 1 upon 6 minus x and its opposite phase is 1 upon 6 plus x. So now what is the required probability? The required probability is see here, first let us see when the die is rolled twice now. For if it is rolled in once, what will happen? So when it rolled once, what is the probability of obtaining one phase? This is 1 upon 6 minus x and its opposite side 1 upon 6 plus x. Okay now. At the same time, remaining phases are also, they will happen. So what is the probability of the remaining phases? Remaining two opposite phases will be there. So that is, if it is a die, there will be 3 set of opposite phases. So top and bottom, right and left, front and back. So that is 3 set of opposite phases. For first set of opposite phases this is the probability, and the second set of probability is, so he is already saying this is 1 by 6 opposite phases. That is 1 by 6 times 1 by 6. And the third set of opposite phases is 1 by 6 upon 1 by 6. This is the for rolled 1 times. But he is saying that twice, 2 times it is rolled. That is equal to 2 times it is rolled. This is given by the value that is equal to 13 by 96. Very easy problem. So if you find out the value of x, the answer will be there. Okay, you can do option verification. If option is if you put any one of the option here, you can get the answer. Okay, I will solve this problem. So let us see this. So this is 1 by 36 minus x square plus 1 by 36 plus 1 upon 36 is equal to 13 by 96. 13 upon 96. So this is implies 1 upon 36 plus 1 upon 36 plus 1 upon 36. This is by 3 upon 36. So 3 upon 36 means 1 upon 12 minus x square is equal to 13 upon 96. Okay now. So if you multiply with the 2, so you will get 1 upon 6 minus 2x square is equal to 13 upon 96. Okay now. So from this we will get this 2 times x square is equal to 1 upon 6 minus 13 upon 96. So this implies 2x square is equal to, this is 96. So this is a 96 means here how much you will get? 19 minus 13. So this is 2x square is equal to 3 upon 96. So this is equal to 2x square is equal to, this is 3 3s are 3 2s are. So this is equal to x square is equal to 1 by 64. So x is equal to actually plus or minus 1 by 8 you will get. But here it is given that 0 less than x less than 1 by 6. So that value should be only positive, and moreover it should lie between 0 and 1 by 6. So you will take only x is equal to 1 by 8. So in our option A is the right answer. Okay, so it's a very easy problem. It is a biased die. It rolled once. When it rolled once, what happens? So probability of obtaining 3 set of opposite faces will be there. 3 set of opposite faces, that is top and bottom, left to right, front and back. So for first top and bottom we have this. For left and right, this is a probability, and this is a. So such type of thus that die is rolled how many times? 2 times, and the probability is given how much? 13 by sum of the probabilities is given how much? 13 by 96. So just I simply solved this equation and I got the value of x by 8. So without solving this also, just by substituting this value here 1 by 8, you can do the option verification also. Okay. So I hope that you understand this solution. So let us go for next problem. So dear students, welcome to our second problem. Okay. The problem is this. A fair die is tossed until 6 is obtained on it. Let x be the number of required tosses, then the conditional probability, that is probability of x greater than or equal to 5 given x greater than 2 is. So it was asked in 26/8/2021 evening shift paper. So those are the options. Okay, first he is saying one word, that is a conditional probability. Okay, first I will explain what is that conditional probability. Okay, that means probability of A given B. What is that? Probability of A given B. That means the probability of happening of A after the happening of B. That means first B should happen, after that A should happen. Okay, the probability of happening of A after the happening of B is given by the formula probability of A intersection B by upon probability of B. Of course, probability of B is not equal to 0. Why? Because first the probability of B should happen. If it is happen, afterwards what is the probability of happening of A? That is given by probability of A intersection B upon probability of B. Okay, right, here obviously both A and B are independent events. Okay, right. So if you know that basic formula, then we can easily solve this main problems. Okay, so let us start the solution of the main problem. So dear students, welcome to the main solution. See here, first probability of x greater than or equal to 5 given x greater than 2. So this is given by the formula, that is In previously I explained, in place of A, x greater than or equal to 5 is there. In place of B, x greater than 2 is there, strictly greater than 2. So, from this formula conditional problem, probability of x greater than or equal to 5 intersection x greater than 2 upon probability of x greater than 2. Okay now. So, coming to the numerator, x greater than or equal to 5 intersection x greater than 2. So, what is that? If you see the number line, if you see on the number line, this is 2 and it is 5. Okay now. X greater than or equal to 5 means what? Including 5 right side part, everything will come, all numbers will come. X greater than 2 means what? That is except as all right side part. What is the intersection you will get? This is the intersection, that is x greater than or equal to 5 you will get, obviously x greater than or equal to 5. So, this is equal to probability of x greater than or equal to 5 by probability of x strictly greater than 2. Okay now. So, now I will find out the value of numerator separately, I will find out the value of denominator separately. Okay. So, first take the probability of x greater than or equal to 5. Probability of x greater than or equal to 5 means what? Probability of x is equal to 5 plus probability of x is equal to 6 plus so on infinity. Okay now. Now coming to probability of x is equal to 5. See here, now coming to the problem. A fair die is tossed until 6 is obtained. Okay now, until 6 is obtained. So the die is here fair die. Fair die means already I explained in the first problem. Fair die means or unbiased die. What is the probability of obtaining 6? That is 1 by 6. What is the probability of not obtaining 6? That is 5 by 6. That fair die is tossed until 6 is obtained. Let x be the number of tosses. So here the number of tosses are how many? 5 times you tossed. That means first 4 times you failed and 5th time you got success. That means first 5 times you failed means what? What is the probability of failing here? That is not getting 6. That is 5 by 6. This is equal to 5 by 6 into second time failed, first time failed, second time failed, third time also failed, right? Fourth time also failed. The 5th time you are success. Plus. Okay now. Next one, x is equal to 6. X is equal to 6. That means that coin is x be the number of required tosses. That means after 6 tosses, if you toss the coin 6 times, you are getting the number 6. That means what? First time you are failed, second time you failed, third time you failed, 5th time is also you failed, first time, second time, third time, fourth time, 5th time is also you failed, 6th time you are success. That is 1 by 6 plus if it is goes on, right? That means what? 1, 2, 3, 4, 5. This time probability of x is equal to 7 means first time fail, second time fail, third time fail, fourth time fail, 5th time failed, 6th time is also failed, 7th time you are getting the number 6. The probability of getting the number 6 on the face is 1 by 6 and the remaining first 6 tosses are failed, right? So let us calculate this value. Let us calculate this value. If you take all these values, you can take the common part. This as a 5 by 6. This you can take it as a common part. This is a 5 by 6 whole to the power of 4 into 1 by 6 you can take common. If you take, that means total term you can take common. So here what you will get? First 1 you will get. So here 5 by 6 you will get. There 2 5 by 6 will come, that is 5 by 6 whole square will come, so on infinity. Okay now, right. So this is equal to 5 by 6 whole power 4 in times 1 by 6 enter. If you observe this is an infinite geometric progression. Since the common ratio is 5 by 6, which lies between 0 to 1, therefore it goes on infinite geometric progression. So we know that infinite geometric progression S infinity is equal to A by A upon 1 minus R, where A is first term, R is common ratio. What is the first term? First term 1 upon 1 minus. What is the common ratio? See here, every term is obtained by multiplying 5 by 6. What is the R value? 5 by 6. So this value. Understand this. So let us calculate this value. This is 5 by 4 by 6 by 4 into 1 by 6 into. So if you observe this, 1 upon 1 minus 5 by 6 is 1 upon 1 by 6. 1 upon 1 by 6 means how much? 6 you will get. Okay, 1 upon 1 by 6, 6. So you will get 6 will cancel. So our value is 5 by 4, 6 by 4. 5 by 4 upon 6 by 4. Okay, so first we have find out in the numerator value x greater than or equal to 5. Now let us find the value of probability of x greater than 2. Okay, so let us continue our solution. So dear students, let us continue the solution. So here in the numerator value, how much we got? Probability of x greater than or equal to 5 is given by 5 upon 6 whole power 4. Let us see the probability of x greater than 2. X is strictly greater than 2. That is equal to probability of x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5 plus so on, it is go on. So here x means what? The number of required tosses. Here 3 tosses are required to obtain the number 6. 3 tosses means what? First 2 tosses failed. In the third toss you will get the number 6. First 2 tosses fail means what? What is the probability of getting failed? This is equal to 5 by 6. First toss failed. Second toss is also failed, and third toss is success, that is 1 by 6 plus. So here also, here 4 tosses are required to get the number 6. So that means first 3 failed, that means 5 by 6, 5 by 6, 5 upon 6 into 1 by 6. Understand? So like that. So here 5 tosses means first 4 tosses are failed. First this is failed, failed, failed. This is success plus so on infinity. Right. So let us calculate this value. So if you observe in each term you have 5 upon 6, 5 upon 6, 1 upon 6. So you can common take 5 by 6 whole square upon 1 by 6. If you take common outside, so the first value is this is 1. So here you will get 5 by 6, here you will get 5 by 6 whole square plus so on infinity. Okay now, so this is equal to given by this is 5 by 6 whole square times 1 by 6. So this is an infinite geometric progression. So previously I explained the formula S infinity is equal to A by 1 minus R. So here R value is 5 by 6. It lies between 0 to 1. Therefore, it will become an infinite geometric progression. So A upon 1 by R. A means 1 by 5 by 6. Okay, this is equal to 5 by 6 whole square times this is a 1 by 6 times. So see here 1 upon 1 minus 5 by 6. So this is equal to 1 upon 1 by 6. This becomes 6. So 6 is cancelled. This is equal to 5 by 6 whole square. Okay. So what is the probability of x greater than 2 we got? So this is 5 by 6 whole square. Okay now. So some more final calculation we will do. So let us continue our solution. So dear students, let us continue our solution. So we obtained the values of both numerator and denominator. So the numerator we got how much? 5 by 6 whole power 4 upon denominator 5 by 6 whole square. So after cancellation, how much get? 5 by 6 whole square we will get whole square. So 5 upon 6 whole square is equal to how much? 25 by 36. 25 by 36. So your option B is the right answer. Understand? So once you go through this problem, this is a problem on conditional probability. I hope that you understand this solution. So let us go for third problem. So dear students, welcome to our third problem. If A and B are two independent events, the probability that both A and B occurs is 1 upon 8, and the probability that neither A nor B occur is 3 upon 8. Then the probability of the occurrence of A is. So this is a problem taken from our Senge's textbook. Okay, now, right. So to do this problem, so we should know one basic idea, that is independent events. The basic idea is independent events. What is meant by independent events? We have A and B are two independent events. Two independent events. Then we have probability of A intersection B is equal to probability of A times probability of B. Probability of A intersection B is equal to probability of A times probability of B. And also we know that if A and B are two independent events, then their complements, that means A complement and B complement, are also independent events. That also we should know. Okay, that is the second one. Third one, we know that the probability of A and the probability of its complementary event is equal to 1. Probability of A and the probability of its complementary event is equal to 1. So if you know all these three items, we can know, if you know all these concepts, we can solve this problem very easily. Okay, now, so let us solve the main problem. So dear students, welcome to the main solution. Okay, so here, see here, the solution is like this. The probability that both A and B occur is 1 by 8, 1 upon 8. That is probability of A intersection B is equal to 1 upon 8. The probability of that neither occurs, that means neither A and nor B occurs, that is equal to probability of A complement intersection B complement is equal to 3 by 8. So from these two equations, we have to find out probability of A. The question is very clear, right? So it's given that both A and B are two independent events. Just now I told, if A and B are two independent events, we have probability of A times probability of B is equal to 1 upon 8. Okay, now, so here also probability of A complement times probability of B complement is equal to 3 upon 8. Okay, now, right. Why? Because if A and B are independent events, their A complement and B complement are also independent events. Okay. So for this I wrote probability of A complement. I will write down what is that probability of A times 1 minus probability of B is equal to 3 upon 8. Okay, if you multiply this, you will get 1 minus probability of A plus probability of B plus probability of A times probability of B is equal to 3 by 8, 3 upon 8. Okay, now, so 1 minus probability of A plus probability of B, we don't know. Right. Probability of A times probability of B is, here we got the answer. This is 1 by 8 is equal to 3 by 8. Okay. So if you solve this equation, so you will get probability of A plus probability of B is equal to 3 by 4. So you call it as equation number 1, you call it as equation number 2. So we have two equations. The first equation is probability of A times probability of B is equal to 1 by 8. Probability of A plus probability of B is equal to 3 by 4. From these two equations, we have to solve this. We have to solve the probability of A separately. Okay now, so let us continue our solution. So dear students, let us continue the solution. Okay now. So here probability of A plus probability of B is we got as 3 upon 4. Probability of A times probability of B is equal to 1 upon 8 we got. So yes, we can solve these different methods we can solve. So in place of probability of B, we can write down 3 upon 4 minus probability of A. We can solve the equation like this. So let us take that is equal to probability of A times, in place of probability of B, you can write down 3 by 4 minus probability of A, that is equal to probability of A. This is a probability of B. In place of probability of B, I wrote 3 upon 4 minus probability of A is equal to 1 upon 8. Okay, so for our convenient, let us take probability of A is equal to X. That is our convenient. Okay, so this is equal to X upon X times 3 by 4 minus X. This is equal to 1 by 8. So multiply this, 3x by 4 minus x square is equal to 1 by 8. Okay, now multiply with the 4. So this is, or you multiply with the 8. So this is equal to 6x minus 8x square is equal to 1. Okay now, so if you put it in a order, so you will get this is a 8x square minus 6x plus 1 is equal to 0. So 8x square minus 6x plus 1 is equal to 0. So if you solve this equation, so you will get the two roots as 1 by 2, 1 by 4. 1 by 2. So you solve it, you will get the answers as 1 by 2, 1 by 4. Therefore, your probability of A is either 1 by 2 or 1 by 4. Understand? So it's a very easy problem. This all depends on independent events and it is a calculation part. Okay now. So I hope that this is our today's class. Okay. So so far I explained this probability and permutations and combinations for all these classes. So we are given a link. So if you want any solutions for these important problems, you can go through the link. Okay now. Okay, so we will see in the tomorrow's class. Okay, bye.